Let's take a look at command line basics, displaying a calendar of the current month. At the command line, there is a simple command that you can use to display a calendar of the current month. Cal. Let's take a look at command line basics, displaying the current date and time. At the command line, there is a simple command that you can use to display the current date and time, the date command. Let's take a look at command line basics, pwd. pwd is one of the simple commands that you need to learn. pwd stands for print working directory. This command gives us the location where we're currently located in the directory structure. Let's take a look at the manual page. pwd prints the name of the current working directory. There are a couple of options which you usually won't need to use. When we run pwd currently, we see that I'm in my home directory. We can explore other places in the file system and use pwd to identify where we are. Let's use the cd command to go somewhere else. Let's try a few more. You'll see that wherever I go, I can use pwd to find out the location where I am. Let's take a look at command line basics, using exit to end a terminal session. When you are done at the command line, it is good practice to explicitly terminate your bash terminal session. This is done using the command exit. After you execute this command, your bash session ends. If you were connected to a remote server via SSH, as I was here, executing the exit command also terminates your SSH session. Let's take a look at command line basics, using up and down arrow keys to navigate the command history. Let's begin by running a few simple commands. We'll start by running a command to see the current date and time. Next, we'll print a simple message. And next, let's display a calendar of the current month. When working at the command line, it is likely that you may want to run a command again. Bash provides a simple mechanism for navigating the commands that you have used recently, the up arrow and the down arrow. Pressing the up arrow will instruct Bash to recall the previous command from the list of recently used commands. Let's try pressing the up arrow. As you can see, the most recently used command now appears. Let's try pressing the up arrow again. The next most recently used command, which in this case was echo, now appears. Let's try pressing the up arrow again. The next most recently used command, which in this case was date, now appears. Just as we can use the up arrow to navigate backwards in time through the command history, we can also use the down arrow to navigate forwards in time through the command history. Let's try pressing the down arrow. Doing so takes us forward one command to the echo command. Let's try pressing the down arrow again. Doing so again takes us forward one command, this time to the cal command. And finally, let's press the down arrow one more time. Doing so takes us back to an empty command line. This corresponds with where we were before we first pressed the up arrow. Let's take a look at command line basics, using left and right arrow keys to navigate within the current command. Let's begin with a command that displays a simple message. After entering this command, what can I do if I want to change what I just typed? One option would be to delete what I typed using the backspace key, and then type something else. However, there is a more efficient option. By using the left and right arrow keys, I can navigate backwards and forwards within the command as I type. Let's take a look at command line basics. mkdir. mkdir is used to create directories. After using mkdir to create a directory, we can use the ls command to verify that that directory was successfully created. Let's try again. This time, let's ask mkdir to be verbose. By calling mkdir with the -v flag, mkdir prints a message for each created directory. We can, of course, still use ls to verify that the directory was created. mkdir can also be used to create multiple directories at one time. If you attempt to create a directory and a directory with that name already exists, mkdir will produce an error message. In the previous examples, we created directories directly within the current working directory. It is also possible to use mkdir to create directories elsewhere. This command creates a subdirectory called edu inside the src directory. This behavior can be extremely useful. However, be advised that if the parent directory does not exist, mkdir will produce an error message and will fail to create the subdirectory. This command failed because the examples directory doesn't exist. There's a solution. Let's take a look at the manual for mkdir to find it. The -p flag instructs mkdir to make parent directories as needed. The -p flag can also be used so that mkdir doesn't complain if the directory already exists. Recall that we already created a directory called bin. As we saw earlier, if we try to create a directory that already exists, mkdir will normally fail. But by calling mkdir with the -p flag, mkdir will silently succeed. In all of the examples so far, we've asked mkdir to create directories within the current working directory. We can alternatively call mkdir using absolute paths. mkdir is an essential Linux command that you will use frequently. You should practice using it to create directories in your current working directory and elsewhere. While you may never use the -z or -m flags, you should learn to use the -p flag. Let's take a look at command line basics, using ls to list the contents of the current working directory. ls is one of the most commonly used commands. Let's take a look. If I run ls with no arguments, it will display the contents of the current working directory. We can now see that this directory contains 5 other directories: baz, foo, homework, canlm, and zork. Let's navigate to another directory. And use ls to view its contents. We can now see that the current working directory, canlm, contains a number of files and directories. Now, let's use cd to change to a different directory. Now, if I run ls with no parameters, it's going to print the contents of the current working directory, which is /user. In conclusion, invoking ls with no parameters will display the contents of the current working directory. Let's take a look at command line basics, using less to view text files. When working at the command line, it is likely that you will commonly want to view the contents of various files you were working with. There are a number of programs you can use to accomplish this goal. One of the most widely used programs for viewing text files is less. Like many programs you will encounter, the name less is a play on words. Less was developed as a more fully featured replacement for an earlier text viewing application whose name was more. Less can be used to view the contents of text files. Notice that unlike on Windows, on Linux, file extensions such as .md, .txt, .zip, and .py are not meaningful. Even though readme.md has an extension, it is still a plain text file and can be opened by less. Less can be navigated, page up and page down, using various key shortcuts, including space to page forward and B to move backwards. To exit less, press Q. Less has lots of options. One helpful option is the display of line numbers. This option can be enabled with the -N flag. Notice that if necessary, less will wrap lines if the line is too wide to be viewed on the current display. Line 10 in this file begins here, but continues through here. This line is marked as line 10 throughout. Let's take a look at some other files. Here is George Washington's inaugural address. And here is Johnson's. And here is Obama's. The text files don't have to be in English. Less is capable of displaying text in other languages. For example, here's a Swadesh list for Russian. Less can also open more than one file at a time. When using less to view multiple files, the command :n is used to navigate to the next file. And the command :p is used to navigate to the previous file. Less is one of the most commonly used programs you will encounter when using the command line. It is well worth your while to learn how to use it and to learn some of its more commonly used shortcuts. Let's take a look at command line basics, using ls to list the contents of a non-current directory using a relative path. Let's take a look. If I run ls with no arguments, it will display the contents of the current working directory. ls also accepts an argument. When I provide an argument to ls, it will list the contents of that directory rather than the current directory. So here we see that there are a number of files and directories within the kenlm directory. If we want to see the contents of one of these subdirectories, one approach would be to use cd to navigate to that subdirectory and then use ls to view its contents. However, there is a faster way. Let's go back to the home directory and try the faster way. Rather than calling cd and then calling ls, we can directly call ls, providing the directory as an argument. In the above invocation of ls, we provided a relative path, kenlm/include, as an argument to ls. After doing so, ls listed the contents of the specified directory. We can also call ls using other relative paths, including those that make use of dot and dot dot. Recall that dot dot refers to the parent of the current working directory. In this case, the parent of the current working directory is kenlm. Let's try another. In this case, dot dot refers to the parent of the current working directory, kenlm. And dot dot slash util refers to the util directory that is within the kenlm directory. Let's take a look at command line basics, using ls to list the contents of a non-current directory using an absolute path. Let's take a look. If I run ls with no arguments, it will display the contents of the current working directory. ls also accepts an argument. When I provide an argument to ls, it will list the contents of that directory rather than the current directory. So here we see that there are a number of files and directories within the kenlm directory. If we want to see the contents of one of these subdirectories, one approach would be to use cd to navigate to that subdirectory, and then use ls to view its contents. However, there is a faster way. Let's go back to the home directory and try the faster way. Rather than calling cd and then calling ls, we can call ls directly, providing the directory as an argument. In the above invocation of ls, we provided an absolute path, /home, /lanes, /kenlm/include, as an argument to ls. Let's take a look at command line basics, identifying and understanding symbolic links. Let's take a look. So far, everything looks normal. User bin Python is a file. More specifically, we can use this file to invoke the Python interpreter. Let's look more closely at this file. In the above invocation of ls, we used the -l flag to direct ls to use the long listing format. Notice that in this long listing, there is an arrow. The arrow means that user bin Python is not a regular file. Instead, it is a symbolic link that points to another file. In this case, user bin Python points to the file Python 2.7. We can confirm that user bin Python is a symbolic link by invoking the program file. File can be used to determine the type of a file. This confirms that user bin Python is a symbolic link. Let's take a look at user bin Python 2.7. We see now that user bin Python 2.7 is an actual executable file. So, when we call Python, the system redirects our call so that Python 2.7 is called instead. Now, let's look at a slightly more complex example. We see that user bin Emacs is a symbolic link to Etsy alternatives Emacs. Okay, that's a little strange. Normally executable files are located in user bin, not in Etsy. Let's take a look at Etsy alternatives Emacs. We see now that we have another symbolic link. Etsy alternatives Emacs is actually a symbolic link to user bin emacs24x. So, when we run user bin emacs, the system redirects our call twice. First, to Etsy alternatives emacs, and then finally to user bin emacs24x. In conclusion, symbolic links, like shortcuts in Windows and aliases in the Mac OS, provide a mechanism for referring to another file. Symbolic links can be easily identified by using ls with the -l flag, and also by using the file command. Let's take a look at command line basics, using ls to view hidden files. If I run ls with no arguments, it will display the contents of the current working directory. We can see now that this directory contains 5 other directories: baz, foo, homework, canlm, and zork. However, this directory actually contains a number of other hidden files. By default, ls ignores any file whose name begins with dot. We can force ls to display these otherwise hidden files by using the -a flag. As you can see, when we invoke ls with the -a flag in the home directory, a number of hidden files can be seen. Let's take a look at command line basics, using ls with additional options. If I run ls with no arguments, it will display the contents of the current working directory. We can now see that this directory contains 5 other directories: baz, foo, homework, canlm, and zork. There are a number of additional options we can use to configure ls. One commonly used option is the -l flag. The -l flag causes ls to use a long listing format. Using the long listing format shows us additional information for each file. This information includes the file type, file permissions, the owner, and group associated with the file, the file size, the modification date, and the file name. The file sizes reported by ls-l aren't particularly readable. By using the -h flag, ls will report file sizes in a more human-readable format. Notice that when we specify multiple flags, we can either list each flag separately or list the flags together. The above two commands are equivalent. There are a number of other useful flags in ls, which can be found by reading through the ls man page. Let's take a look at command line basics, using rm to delete files and directories. Let's take a look. The rm command can be used to delete files. Let's use rm to delete the file license in the current directory. After using rm, the specified file has been deleted. Note that by default, rm does not prompt you for confirmation. It simply deletes the file. If you use the -i flag, rm will prompt you for confirmation before it begins deleting files. Let's use rm to delete a file in the foo directory. Because we specified the -i flag, rm prompted us for confirmation before it deleted the file. Let's see what happens if I say no. rm did not delete the file. Let's try again, and this time we'll say yes to the confirmation. We can also use the -v flag to force RM to explain what is being done. Let's try removing another file, this time using the -v flag. By invoking RM with the -v flag, RM printed a message confirming that the file was deleted. We can also invoke RM with an absolute path. Now, let's try to use RM to delete the foo directory. What just happened? We called RM, providing foo as the argument for what to delete. And RM failed to delete the directory. Let's look at the man page for RM to see if we can figure out what just happened. By default, RM does not remove directories. To force RM to remove a directory and any contents it might have, we can invoke RM with the -r flag. In many cases, especially when you are new to the command line, it is advisable to use the -I or -I flag when invoking RM recursively. Here, we'll use the -I flag. We will also use the -v flag so that RM will confirm what files it deletes. Let's take a look at command line basics, using cd to navigate to a directory using a relative path. Let's take a look at where we are, the current working directory. Now, let's use ls to view the contents of the current working directory. We can use the bash built-in command cd to change directories. To use cd, we provide the name of the directory into which we wish to navigate. Let's use pwd to verify that we've changed directories. Notice that in the above invocation of CD, we only specified the name, Baz. We did not type /home/lane_s/Baz. This style of referring to a directory by only part of its name shows the use of CD using a relative path. The absolute path in this case would be /home/lane_s/Baz. The relative path that we used was simply Baz. Because we were located in the directory /home/lane_s at the time we invoked CD, the part of the path corresponding to the current directory can be omitted through the use of a relative path. There are two special relative path components, dot and dot dot. Dot refers to the current working directory. Dot dot refers to the parent of the current working directory. Let's recall where we are. The current working directory, Baz, is located within the directory lane_s. We could refer to the parent by its absolute path, /home/lane_s, or we could refer to it as dot dot. Let's use CD and dot dot to navigate to the parent of the current working directory. Let's practice some more. What just happened? We told CD to navigate to dot. Dot is another name for the current working directory. Consequently, we stayed in the same current working directory. In other words, we didn't go anywhere. What just happened? We were in /home/lane_s/foo. We used dot dot twice. From /home/lane_s/foo, dot dot would refer to the parent directory, /home/lane_s. But we used the relative path dot dot slash dot dot. If dot dot is the parent, then dot dot slash dot dot is the parent of the parent. In this case, the parent is /home/lane_s, and its parent is /home. So, invoking CD dot dot slash dot dot from home lane_s foo takes us to home. Notice what we just did. We used a relative path, lane S / kenlm, to navigate from /home to /home /lane S / kenlm. We could have called CD twice, but this way was faster. Let's go back and see the slower way. We used CD here to navigate one directory at a time. Just as we can use ls to look into subdirectories, we can also use CD to navigate directly into subdirectories. Let's take a look at command line concepts. Understanding complex relative paths using dot and dot dot. Now, let's take a look at one example of a relative path that uses both dot and dot dot multiple times. Now, let's go back and take a closer look at this complex relative path. We'll begin by visualizing the directory tree in which we're operating. The directory tree looks like this. For convenience in keeping track of subdirectories, I have color-coded the subdirectories we'll be discussing. The current working directory is /home /lanes /kenlm /util /stream. Notice that I've color-coded the names in this path to match the corresponding subdirectories in the directory tree. Now let's look at our complex relative path. Again, notice that I've color-coded the names in this relative path to match the corresponding subdirectories in the directory tree. Dot dot, which you see here in red, refers to the parent of the current working directory. In our case, the parent is the util directory, which is also drawn in red here in the tree. Double conversion is a subdirectory of util. Thus, given that stream is the current working directory, / double conversion refers to the subdirectory colored in gold in the tree. /home /lanes /kenlm /util /double conversion. Dot is another name for the current directory. This means that ... /double conversion /dot means exactly the same thing as ... /double conversion. The parent of double conversion is util. Thus, ... /double conversion /dot /dot refers to the red node in the tree, whose absolute path is /home /lanes /kenlm /util. The parent of util is kenlm. So, ... /double conversion /dot /dot refers to /home /lanes /kenlm, which we see colored orange in the tree. lm, which you see in blue, is a subdirectory of kenlm. So, ... /double conversion /dot /lm refers to /home /lanes /kenlm /lm. And because dot, which we see here in blue, refers to the current directory, ... /double conversion /dot /lm /dot refers also to lm. Wrappers is a subdirectory of lm. So, ... /double conversion /dot /lm /dot /wrappers refers to /home /lanes /kenlm /lm /wrappers. ... which we see here in blue, refers to the parent of the current working directory. So this path refers to LM. And finally, builder is a subdirectory of LM. And so, // double conversion /dot /dot /lm /dot /wrappers /dot /builder refers to home, lane s, ken lm, lm, builder. Let's take a look at command line concepts. Understanding complex relative paths using dot and dot dot. Now, let's take a look at one example of a relative path that uses both dot and dot dot multiple times. Note that the following example is intentionally complex, deliberately made convoluted to illustrate how dot and dot dot can be used within other paths. It may be a while before you encounter an example that's this complex in real life, but it is good to understand what's going on. Now, let's go back and unpack that messy path. Dot dot refers to the parent of the current working directory. In our case, the parent is the util directory. Double conversion is a subdirectory of util. Its absolute path is /home /lane s /ken lm /util /double conversion. Dot is another name for the current directory. that means // conversion /dot means exactly the same thing as // double conversion. The parent of double conversion is util. The parent of util is canlm. So, // double conversion /dot /dot refers to home lanes canlm. lm is a subdirectory of canlm. So, // double conversion /dot /lm refers to home lanes canlm lm. And because dot refers to the current directory, // double conversion /dot /lm /dot is the same as // double conversion /dot /lm. Also referring to home lanes canlm lm. Wrappers is a subdirectory of lm. So, // double conversion /dot /lm /dot /wrappers refers to home lanes canlm lm wrappers. Dot dot refers to the parent of the current working directory. So dot dot slash double conversion slash dot dot slash dot dot slash lm slash dot slash wrappers slash dot dot refers to home, lane s, kenlm, lm. And finally, builder is a subdirectory of lm. So dot dot slash double conversion slash dot dot slash dot dot slash lm slash dot slash wrappers slash dot dot slash builder refers to home, lane s, kenlm, lm, builder. Let's take a look at command line basics. Using cd to navigate to a directory using an absolute path. Let's take a look at where we are, the current working directory. Now, let's use ls to view the contents of the current working directory. We can use the bash built-in command cd to change directories. To use cd, we provide the name of the directory into which we wish to navigate. Let's use pwd to verify that we have changed directories. Notice that in the above invocation of cd, we specified the full path /home /lanes /baz. This style of referring to a directory by its full name shows the use of cd using an absolute path. Let's navigate somewhere else. In the above command, the absolute path that we used was /user/local. Notice that an absolute path always begins with a slash. The layout of the Linux directory structure is a tree. There is a single unique root of the file system tree. The notation / represents the root of the file system. All directories have / as their ultimate ancestor. Every absolute path begins with /. Every absolute path specifies a sequence of contains relations, beginning with the current file or directory and ending at the root of the file system. Let's look at another absolute path. We used cd to navigate to /user/share/man. /user/share/man is an absolute path. Let's decompose this absolute path to understand it better. Man is a directory. We can use ls to view its contents. The parent directory of man is share. In other words, the share directory contains the man directory. Let's verify this by using ls to view the share directory. The share directory contains the man directory. The parent directory of share is user. In other words, the user directory contains the share directory. Let's verify this by using ls to view the user directory. The user directory contains the share directory. And finally, the parent of user is root. In other words, the root directory contains the user directory. Let's verify this by using ls to view the contents of the root directory. The root directory contains the user directory. Let's take a look at command line basics, using cd without options to navigate to the home directory. Let's take a look at where we are, the current working directory. We are currently located in the home directory. Each user has a unique home directory. The path of the home directory can also be observed by printing the value stored in the home environment variable. Now, let's navigate to a different directory. Let's use pwd to verify that we have changed directories. Now, let's call cd again. This time, we're going to call cd without providing a directory path. What just happened? Normally, when we call cd, we provide a relative or absolute path to a directory, and cd then takes us to that specified directory. In this case, we didn't provide a directory. So where did we go? Let's use pwd and the documentation for cd to figure out what just happened. By running pwd, we can see that cd took us to the home directory. Each user's home directory is different. My home directory is /home/lanes. We invoked cd without any options. Doing so took us to the home directory. Let's take a look at the documentation for cd to find out why. Recall that cd is a bash built-in command. Documentation for bash built-in commands can be accessed using the help command. The documentation states that cd is used to change the shell working directory. Specifically, cd is used to change the current directory to dir. Normally, dir is provided by the user. However, the square brackets in the usage means that providing this value is optional. In other words, users are allowed to call cd without providing a directory. When this happens, cd falls back to a default value for dir. The default dir is the value of the home shell variable. As we saw earlier, the home shell variable stores the value of the user's home directory. Thus, calling cd without any options takes us to the home directory. Let's take a look at command line basics, using mv to move files. The mv command can be used to move files. mv takes two mandatory arguments. When moving a single file, the first argument is the path to the file you want to move. The second argument is the path where you want the file moved to. In the above invocation of mv, I moved the license file from the kenlm directory. The result is a file in my current working directory called abc. Another way to invoke mv is by giving mv a destination directory. For example, let's say we wanted to move the file abc from the current directory into the directory baz. To do so, we call mv using abc as the source file and baz as the destination directory. As you can see, after the above invocation of mv, the baz directory now contains abc. Usually, it is not necessary to supply any options to MV. However, if you want confirmation of what MV is doing, invoking MV with the -v flag will explain what is being done. By calling MV with the -v flag, MV confirms that it moved the file baz/abc to kennelm/license. MV can also be used to move multiple files to a common destination directory. Let's use touch to create several empty files. Now, let's use MV to move all 4 of these files into the foo directory. The ... notation here indicates that MV allows us to specify multiple source files. As you can see, all 4 files have been moved to the foo directory. Let's take a look at command line basics, using cd to navigate using tilde. Let's take a look at where we are, the current working directory. We are currently located in the home directory. Each user has a unique home directory. The path of the home directory can also be observed by printing the value stored in the home environment variable. Let's look and see what other users have home directories on this system. Navigating to or referring to a user's home directory is so common, there is a special shorthand syntax for doing so: tilde. The notation tilde username refers to the home directory for username. For example, let's try navigating to the home directory for the user Bryce2. We can use pwd to verify that we have successfully navigated to the home directory for the user Bryce2. Let's try again with another user. I can also use this notation to refer to my own home directory. My username on this system is lanes, so I can refer to my own home directory using tilde lanes. It turns out that referring to your own home directory is even more common than referring to someone else's home directory. Consequently, there's an even shorter shorthand notation for referring to your own home directory. Tilde. When used as a directory, a bare tilde without an accompanying username refers to the user's own home directory. You can also use this notation to refer to files and directories within your home directory. Notice that in the above invocation of cd, tilde/kenlm refers to the kenlm directory that is in my home directory. In conclusion, the notation tilde username can be used to refer to the home directory associated with the specified username. For example, and the notation tilde can be used to refer to your own home directory. Let's take a look at command line basics, using ln to create symbolic links. The ln command, when used with the -s flag, can be used to create symbolic links. Symbolic links, like shortcuts in Windows and aliases in the Mac OS, provide a mechanism for referring to another file. In its first form, ln takes two mandatory arguments. The first argument is the path to a file that already exists. The second argument is the path where you want the new symbolic link created. In the above invocation of ln, I created a new symbolic link called abc that points to the license file in the kenlm directory. abc is not a copy of license. It is a symbolic link to license. We can verify this by using the file command to ascertain the type of abc. We can also verify this by calling ls with the -l flag. The long file format shows that abc is a link, and that it points to kenlm/license. Now, let's take a look at the second form of invoking ln. In the second form, we only provide the path to the file that already exists. When we invoke ln in this manner, providing only a single file as an argument, ln creates a symbolic link to that file with the same name in the current working directory. The third form of invoking ln is more advanced and can involve some additional subtleties, so we'll cover that in a separate video. Let's take a look at command line concepts, using ln to create symbolic links in another directory. The ln command, when used with the -s flag, can be used to create symbolic links. Symbolic links, like shortcuts in Windows and aliases in the Mac OS, provide a mechanism for referring to another file. We're going to look at the third form of invoking ln. The first argument is the path to a file that already exists. The second argument is a directory in which you want the new symbolic link created. Something's not right here. The symbolic link is broken. Let's remove the broken link and try again. In the above invocation of ln, we attempted to create a symbolic link in another directory. When we provided the first argument, it was a relative link. This use of a relative link in the third form of ln is the cause of our broken link. There are a couple of possible solutions. The first solution is simply to use an absolute path instead of a relative path. Now, let's remove the symbolic link and figure out how to make a symbolic link in another directory using a relative path. Let's try to figure out why this link is broken. Within the baz directory, license is a symbolic link pointing to kenlm/license. kenlm/license is a relative path. Within the baz directory, what does the relative path kenlm/license mean? Well, it would mean that there should be a directory, a subdirectory, called kenlm within the current directory, baz. And within that subdirectory, there should be a file called license. There's the problem. Is there a kenlm directory inside baz? No, there's not. We just ran ls from within baz, and there is no kenlm subdirectory. The broken link is looking for something that doesn't exist. That's why it's broken. We can confirm this by using readlink to determine the absolute path that the symbolic link is attempting to point to. This confirms that the symbolic link is looking for a file that doesn't exist. /home/lanes/baz/kenlm/license. So what would happen if the missing file were to be created? Let's find out. To do so, let's create a directory called kenlm within the baz directory. Now, let's use the touch command to create an empty file called license within our newly created kenlm directory. Finally, let's see if our symbolic link is still broken. The symbolic link license in the baz directory is no longer broken. Why? Because the file it was looking for now exists. So, our link is no longer broken, but it's pointing to the wrong file. Specifically, it's pointing to the empty file we just created. That's not what we want at all. Let's remove these dummy files and try again. In order to use the third form of ln to correctly create a link, it's helpful to realize two things. First, ln interprets this first argument as a string. And second, if that string represents a relative path, the file system will interpret that relative path relative to the directory in which the symbolic link is to be created. Recall from above that our broken symbolic link was looking for a kenlm directory within the baz directory. So let's think about things relative to the baz directory. From within the baz directory, what relative path can we use to refer to /home /lanes /kenlm /license? Well, kenlm and baz are both in the home directory. In other words, they have a common parent. We can refer to the parent of the current working directory as ... So from the baz directory, ... /kenlm refers to /home /lanes /kenlm. And ... /kenlm /license refers to the file that we want. Armed with that information, let's try making that symbolic link again. It worked. We can use readLink to confirm that the symbolic link is now pointing to the correct file. We have succeeded in creating a symbolic link in another directory using a relative path. To do so, we had to think about the relative path from the perspective of the directory in which the link is being created. It turns out that we can ask ln to do this change of perspective for us. When invoked with the -r flag, ln will create the symbolic link relative to the link location. Let's remove the existing link and give this a try. By running ls-l, we can observe that when the -r flag was passed to ln, ln correctly translated the relative path we provided, kenlm/license, into a relative path that is correct in the context of the baz directory, ... /kenlm/license. Calling readLink confirms that the symbolic link in the baz directory is indeed pointing to the correct file, /home /lanes /kenlm/license. Let's take a look at command line concepts, using file to determine a file's type. Let's take a look. The file command accepts a file name as an argument. the command attempts to determine the type of the specified file. Using file, we observe that user local is a directory. Great. That's exactly what we would expect. Let's look at some more files and use the file command to determine their respective types. The above invocation of file tells us that mailq.1.gz is comprised of data that was compressed using gzip. Here, we see that license is a plain text file encoded using ASCII. Let's take a look at command line basics, using CP to copy a single file. The CP command can be used to copy files. CP takes two mandatory arguments. When copying a single file, the first argument is the path to the file you want to copy. The second argument is the path where you want the file copied to.